Are you facing latency issues in fetching data from a network service or from a third-party API? Are you building auto-scalable, auto-hailable microservices and managing the state of these applications is a big problem for you? Are you managing user session data of your highly available web application and it's becoming a challenge for you? If the answer is yes to any of these questions, then you are on the right session and watching the right video. Welcome to my session on distributed caching with Redis for Spring Boot applications. I'm Sashi Perry, Principal Architect with RDB. Before we get into the content, here is my disclaimer. This session is intended to outline the general direction and is my view intended for information purposes only. You are encouraged to do your own thorough research and analysis before the use of the technology in your production-grade application. Now let's take a quick look at the session overview. I divided the session into 3 parts. The part 1, we will cover what's distributed caching and why is it important, and why use Redis as distributed caching manager. We will look at few popular read-write caching patterns in the context of APIs. We will see few use cases and common pitfalls. Then we will move on to the demo in which we will implement read-write cache patterns in a Spring Boot application with spring-data-redis. We will use 2 types of APIs for this purpose. A customer API with MySQL database as primary data store and Books API to simulate third-party API calls and network latency. We will use Google Books API for that. In part 2, we will cover the security aspects. We will see how Redis implemented security and how to manage users and access controls on the server side. Then we will introduce the security into the Spring Boot application that we will build in the part 1 to showcase how security can be handled on the client side. Finally, we will end the module after taking a quick look into search capabilities that RedisJSON and RediSearch combination offers by searching the data that we previously cached. In part 3, it is a special module. In this module, we specifically cover Redis cache as session store, that is to store users' web session data in the Redis. And we will demo that using spring-session-data-redis and using a super simple web application that we are going to build using Spring Boot. Finally, we will conclude this module after looking at cache eviction policies and TTL. Is that all or what more? So these are the questions I captured here that usually come after a session. Like, where is the presentation? Where is the final code? Are you going to make it available? And reference links, and how do I get started, and so on and so forth. So the presentation will be made available on my blog, GitHub pages, and few other channels, which I will provide in the last 2 slides, the links to these blogs and such. And the final code will be uploaded to the GitHub, and I will provide the link as well. And there are many reference links I included, and there are many links to Redis tutorials and videos and so on and so forth to get started, which I also included in the last 2 slides. Now coming to the tools and software I will be using, I will use Docker. And the Redis services that I'm going to use will be hosted in a Docker container that's going to run locally on my laptop. And the Redis services that I would use is the Redis itself, the regular one. And then I would also have another instance of Redis using Redis Stack Server to demonstrate few additional modules. And then I will be running RedisInsight for the GUI purposes to look into the cache more closely. And then we will be using Redis CLI and particularly CLI Monitor. So we could watch what's happening in the cache real time as we make the RESTful calls. And then for this demo, I would be using Java 17 and latest Spring Boot, um, latest version of the Spring Boot. And we will quickly look at Redis Cloud. I'm not going to use Redis Cloud or Cloud Database for the purposes of the demo, but it's worth taking a look at it. Let's get into the part 1 of the video. Now, what is distributed caching? First, let's talk about non-distributed type of caching. For example, caching in memory, which is available within an application within a single process. In the Java world, the most popular in-memory cache is EH cache, for example. Whereas, unlike the in-memory cache, distributed caching is a type of cache that can be shared by multiple applications or multiple instances of the same application. That means it lives external to the applications. Is this a new concept? Now, there were always needs to externalize the cache and make it distributed, and there were few providers. But with the microservices going mainstream, it became even more important, and the need increased to build scalable microservices. And remember the 12-factor applications and the factor number 6 that is talking about stateless processes. Distributed caching could be a solution to make a stateless process. And now let's look at some of the expectations that you may have from a distributed caching provider. For example, you would expect your cache service to be able to span across multiple servers, available across multiple regions, zones, nodes, and so on. And you would probably also expect your cache to be able to grow elastically, shrink or expand. And you would expect it to be highly scalable and highly available, and high performance, data integrity. All these are expectations, and there are more and more, and the needs are endless. But remember Breuer's cap theorem. Cap theorem states that any distributed data store can provide only two of the three factors. The three factors being consistency, availability, partition tolerance. Suppose you are designing a system so its performance is superior, highly available with great partition tolerance. But then for the third factor, which is related to the persistence of the data, probably you are choosing it to be a asynchronous operation. That is, you probably would design your system for eventual consistency. Now, what's the deciding factor? The deciding factor then would be how robust your design and architecture to achieve this eventual consistency, and how accurate are your algorithms, how performant they are to make sure that the sync happens seamlessly and it is fault tolerant. If this aspect is taken care, then effectively all three factors are handled very well. Now, why Redis? There are many distributed caching providers in the market. Then why one may choose Redis? As Redis team says, and everyone says, Redis is blazing fast. And the important thing is that it handles the third factor of the cap theorem that I was mentioning in the previous slide very well. And as I alluded in the earlier slides, Redis handles the stated expectations very well, but there is something more. Redis fundamentally is designed to be a NoSQL database with memory first in mind. It's designed to be a primary data source, and it can do many things. Now let's have a quick look at what else it can offer beyond being distributed caching manager. As we already discussed, it could be NoSQL DB. It supports streams and has PubSub capabilities. It offers superior search capabilities via RediSearch module, such as full text search, document search. For example, documents like JSON can be precisely searched using JSON query paths, which we are going to see in the demo, RedisSearch has great indexing capabilities as well. You can create indexes the way you want your search to work. It can be a document storage store, for example, JSON documents via RedisJSON module. Can be GraphDB with Redis Graph module, Redis time series for monitoring capabilities, Redis AI for AI, TensorFlows, and so on and so forth. There are some more, but this is a gist of what it can do beyond caching. But now you may ask, okay, fine, Redis can do so many things. And yes, it is designed to be a primary data source or keeping the memory first, a database memory first. But how does that matter to me if I am only using Redis as a distributed cache manager only? But think about it. For your application, your cache is a very important data store. It is still an important data store and will have critical data in it. The fundamental design makes it more robust, the design difference. Because it is designed with beyond caching mindset, the functionality it can offer is very rich, and some of these things can be useful even for distributed caching if you use it for its full potential. For example, there are many data types, richer data sets it can support. From a simple map to a complex JSON document, if you use Redis AI, I believe you can have TensorFlows as data sets. It can be a GraphDB, and there are thousands and thousands of public data sets. And I have provided links to these public data sets. You can take a look at it. Now you may ask, should Redis be then this heavy? It's heavy. To begin with, you can start with a simple Redis service, lightweight. And you get all these functionalities as you add more and more modules. You need to build more data structures by adding more modules and get more capabilities. It's pretty modularized that way. Now let's look into some of the popular caching needs and popular caching patterns. Primarily, we have three of the caching needs. That's while you are reading from a primary data source, or writing to the primary data source, and your user session in the web application context. These are the three situations where you would probably externalize your cache. And within the read and write, there are popularly two different patterns. One is doing the cache inline. That's put your cache between your application and the primary data source, and there is look aside right behind. These two are not inline. Fundamentally, both inline and not so inline are same in the sense that they are lazy loaded and they fetch from the cache if it is available. If there is a cache miss, then they go to the primary source and fetch the data. But there are certain subtle differences between inline and not so inline with the way it is written to the cache. And I'm not going to go into the various details of these two types of caches, but I will provide a documentation here in my presentation, which very well explains the differences between the inline and non-inline. Like, for example, this VMware documentation right here has very well outlined and in detail explained. Why I included VMware documentation? Because I'm going to demonstrate it using the Spring application, and they're related. Now, okay, demo time. That's what we are going to do in this demo. So we are going to quickly build a Spring Boot REST API and then implement a type of read catch pattern and a write catch pattern. And we would do it by using two different data sources. That's a MySQL database as a main data source. And then we would also build a caching simulating a third-party API, that is an API that's external to your system, probably hosted by a third party or a different company, and you are reaching there and getting the data. And there definitely will be a lot of latency, and also it all depends on the SLAs that you sign with the third party, and you would have some caching needs there. So we are going to simulate that situation. Now let's jump into the demo. Actually, before going into the demo, let's look at some of the cache providers, the clients, Java clients that are available, the popular ones. Let's is an example, and there is Redis, that's OSS and JSR 107 compliant, and there is Redis. And information about Redis cache providers with all other languages is available in the slides, last two slides. For example, C Sharp, or Angular, React, and so on and so forth. There are Redis clients in, I think, all languages that I can think of. And now, as far as JSR or non-JSR, Spring by default uses Let's. I would guess the reason could be something to do with the project reactor and non-blocking IO capabilities that Let's offers, I'm guessing. But as far as JSR or non-JSR compliance, as long as you are using Spring as abstraction, and in the Spring world, it will use the Spring Cache manager, which binds to both compliant and non-compliant providers. That is, if you have the Java client, the cache provider on the class path, Spring automatically detects and it auto configures for you, whether it is JSR or non-JSR, because then you will be using Spring abstraction. And Spring Cache Manager, it is Spring Cache Manager's responsibility to bind to the appropriate cache manager. So the Spring and the Spring cache annotations are similar to the JSR. And you can use JSR annotations also if you put a JSR compliant cache provider on the class path. So you can essentially, if you go for a Spring cache abstraction, essentially you can switch any Redis client. You can swap one Redis client with another swap client. And from that standpoint, that is, if you are using Spring, no much added value you get, whether or not you are using a JSR compliant Java client or non-JSR, because Spring is providing that abstraction and it will work with a compliant or non-compliant in the same way. And the syntax is similar. With that said, let's jump into the demo. And for that, I'm going to open my Eclipse. So for the demo, we will be using a Spring Boot application. Basically, we will be creating a REST API, and later we will be incorporating the caching into the REST API. And these REST API, like I mentioned in the earlier slides, will be using two data sources. One is the relational database MySQL that's running on my local machine, and the other one as a source, as a third party API. To simulate that, I'm going to use Google Books API and query the books from Google API, which is a REST API, and we catch that to simulate the situation where we are accessing a third party API and there are delays, network latencies, or it's not within the SLA. Whatever is the reason, you want to cache it. Now let's see. I pre-created the application to save some time so we can start incorporating the cache. But I'll walk through the code. The way I created the application is the standard way using the Spring Boot starter. That's the best way. But I did not create from the start.spring.io, but just to walk through how I did. Um, Spring Boot starter project, and Marvin, it's a Maven type project, artifact jar, and I will be, like I said, I will be using Java 17 and I am using Java 17, and leave the group ID artifact ID and Spring Boot latest version, and then Lombok as a dependency, web, Spring Web as a dependency because we are going to create REST APIs. And because I'm going to connect to the MySQL, I would need the MySQL driver and Spring API. I will be connecting to the database using the Spring API and Hibernate implementation. And that creates me the basic minimum project that gives a head start. Cancel. But then I finished the project, and let's go through the code. So let's start with the pom.xml. Like I said, I have only like 3-4 dependencies. That's a Spring starter web, MySQL connector, and the JUnit test automatically added, JPA, and Lombok. That's all the dependencies. The dependencies ended. And now let's look at inspect the application properties. So the application name and the driver class for MySQL, and few application common those are not Spring profile agnostic properties that are common probably across all profiles, which is one of them could be the dialect and the database MySQL and so on. And I'm also saying when you are presenting a HTTP error message, include the message. HTTP error, include the message. This is the configuration I have here. And then the local, because I'm going to use local profile to run the Spring Boot application, I have the database URL configured, user ID, password, and a special property. I said that I will be accessing Google API to fetch the books. It's an external REST API, and the URL is this, and it requires a book ID to be passed. So I configured that as an input parameter, which we will use in the REST template. Now let's look at the controller. And I have two controllers. The customer controller is backed by the MySQL, and book is Google API. Now in the customer API, customer controller, there is a get customer method. It gets all customers. It serves not big of a purpose right now for the demo. And then I have a post mapping. That's a get mapping. I have a post mapping where I would pass the customer payload, and it creates the payload via the customer service. And we will in a while see what the customer service entails. And then I have another endpoint to fetch the customer by ID, and another endpoint to fetch the customer by SSN. SSN is created as a unique key in the database, and ID is the primary key. Now the customer service is been injected via constructor injection, which is a suggested method. Now let's inspect the customer service. And the customer service, the first one, get by ID, is taking the ID that's coming via the REST input, and then it's making a JPA repository call, and it is detaching the customer and returning. Then the get by SSN, similarly getting by SSN. And notice here something important. And oh wait, I don't need this. I'm not implementing any cache. So notice something important, that's the input parameters. And these input parameters will be useful later when we implement the caching, because the Spring abstraction will use the input parameter by default as a key to the named cache. And you can override it. We will see that also. And this is a save method, will be called to write the data into the database. And now let's look at book controller. The book controller again is a simple service that is going to take the book ID and invoke the book service, again injected via constructor injection. And let's look at the book service. And it is auto wiring a REST template. I know it's not a suggested way of injecting a bean, but this is test and it's a simple REST template. I did not use the constructor injection or anything like the controllers, but it's simple auto wiring. And it uses the REST template. And where is the REST template coming from? That's coming from the configuration, which I should have shown first, but we will go there and see how the configuration aspect of this application, the bean configuration. And REST template, simple get for object, and then the URL. Remember, in the URL I have a parameter ID, and that's passed here, and I'm saying the return type is going to be serialized as book. And the entities, here the customer entity, it has, first let's look at the database to get an idea of what this entity is. So I have one record here pre-inserted, and it has field customer ID, which is the auto incremented primary key. First name, last name is SSN, and then last updated by created and updated. In my database right now, for the purposes of the demo, I have only customer. But in the real life situation in production, it's not going to be one table, it's going to be multiple tables, and all the table most likely are going to have a last updated by created and updated. It's like a boilerplate thing, it's going to repeat. So that's why if you look at my entity, these are Lombok, and I have only the unique fields columns that are pertaining to a table here, and then I have an abstract thing created that has these boilerplate kind of a thing using the spring audit. So using the spring audit on create, I automatically set the updated and create to the current date and time, and I hard coded the last updated by. Similarly on up, this is pre-persist, so before you persist, and it's pre-update, then this is these values again are populated automatically. So if I have multiple entities, every entity would extend from this, so every entity will get these fields. That's about the entities. And then the JPA repository, it is simple, it's one repository. Really all I'm going to use is this. I'm not fetching by no service is using these methods, so it's really find by SSN, and the default method that comes with the JPA repository, the CRUD repository. And the configuration aspect, the JPA configuration, the regular simple configuration, I enabled editing for the purposes I just showed the abstract entity part of it, and it's going to scan this package to find all the repositories and inject them into the context. And then the simple REST template. So this is the REST template. This is where the REST template that is used to invoke the Google API is coming from. It's the simplest possible REST template, not OAuth 2, not anything fancy, because it's it can be accessed by anybody. It's public API. Then my controller advice. This is an interesting and important piece. SL4J for logging purpose, injecting the logger. And this is a special thing, the my controller advice. Like the reason is that if you remember, my service is throwing a number of can throw multiple types of exceptions, and I did throw. That is, I'm throwing the exceptions instead of handling in the service all the way up to the stack. And now all these exceptions are handled in one single pace. So for example, if an exception is throwing a 500 error, but it's not really a 500 server error, but there is a reason for it, and it can be presented as a different thing, more friendlier message to the customer. This is where you handle. For example, I'm saying if there is an entity not found is thrown, it's going to result in 500 by the Hibernate. But then I'm converting that as a not found. It's a 400 type of error. data not found, and I give a custom code and MSS. Similarly, some more exceptions are handled, like bad request. If there is an invalid input and that's why some exception is coming, then I handle it. So that's the controller advice. Now I think with that I am done walking through the code. Let's just start it. Oops. And it started. Let's hit the APIs and see what happens. Oh, okay. This is from my previous invocation. Now I got the response because I have only one record. And notice that every time I hit the API, it went to the database and it tried fetching the data. All the time it's hitting the database. You don't see the issue here because it's the database is residing right on my laptop, but in the latter part of the demo I will introduce delay. When I introduce the delay, it will take a while to get the data and to talk to the database and get the data, whereas when it is hitting the cache, it's going to be instantaneous. But for now, this is what it is. And let's see what happens if I do 2. There is no true, no value present. This is coming from Spring, no such element. So if I handle this exception in the control advice, for example, and then add a more friendlier error, that's what would come here. Now hit this. So we could quickly try that actually. But before we try handling the exception, let's post some data and then see what happens. That exception was because there wasn't any such data and I was not handling that properly. Anyway, here now the customer post. So right now in the database, let's take a look. Yeah, there is one record. Let's see. Send it, post it, and see what happens. And on the behind the scenes, it inserted the data and it's available in the database. Now let's inspect something here at this point. The Redis Insight and then what's in here. But before we look into the Redis Insight, let's see the Docker board. As I explained in the earlier slides, I have my Redis running, Redis using Stack Server, and the Redis Insight is running as well. That's this Redis UI. This is the Redis Insight. And let's see what is in the cache. Nothing in the cache. You can't see any of the caches, any of the keys that are cached. These are these music ones I pre-created for a different purpose. We will see why. um, they will come handy when I demo the security aspect in the part 2. I will give access on a certain prefix and not on certain prefix. And we are going to have a prefix that is for this application, maybe demo cache or something, and we are going to group all the keys for this application under that. Then you will start seeing those keys. But for now, nothing is cached. We did not introduce the cache, and we are going to introduce the cache now. Now, to introduce the caching, we need an additional dependency, which is spring-data-redis. And let's once I will refresh. And we got the dependency. Now we need few before even adding the properties. There is one important thing that we need to add here, which is enabling the cache, and we enable the cache with the @enable caching annotation. And then the properties. And now I'm going to add a name prefix at application level. That is its Redis cache prefix. What this means is that every single key that we are going to write in every single cache within this application is going to be prefixed by this. The reason why I do that is to group all the keys under this name to represent this application. This is going to be handy later when we implement the security. And I'm not going to do anything because the application type properties, I'm going to only add properties that are at application level, not environment specific ones. Now I'll go to the environment, add some more things for data Redis. I mean the Redis host and port. It has to be at correct level. And that's correct. So it's this. And as you see, the client name, when it's going to connect to the Redis service, it's going to have this name. It's going to publish the data under this name. This is not so useful as far as this application and for this demo, but it is going to be useful on the Redis side of it, to recognize a client for the administration aspects. And then the host. And notice that I did not give the port because I'm going to use the default port. And Spring automatically deduces the port. It sees the spring-data-redis on the class path, and it auto configures by default the let use, which we discussed in earlier slides. So it gets the let use client, and because it sees that on the class path, it auto configures the cache manager and it binds to the Spring default cache manager. So everything is done automatically, including the port. It by default connects to the default port. I think with this, the configuration aspect is done. And now let's see what else we need to do. I'm going to catch this at service level, not at JPA repository level, because this is not equal. The kind of cache that I want to simulate is not equivalent of Hibernate level 1 or level 2 cache. That's not the intent. So that's why I'm going to do it in the service level. In this service, for the demo purposes, you don't see much but calling a repository. But in real life situation, the service may probably reach out to couple of repositories and maybe aggregate the data, consolidate the data, and that's what you are going to cache. So that's why it's not the level 1, level 2 kind of a thing. So I would put the caching capabilities on the service level, and let's see how that would look like. To do so, I think I'm going to do this. Add catchable. And add catchable, the same cache name customer, except the third one. That's a little different. The save. I'm going to do this. The reason is, so here the customer, what is the key going to be? So Spring by default takes the looks into the input and uses the input as a key. So here in this case, ID would be the key by default, and here in this case it is SSN. So now if I, but here notice that I specified a key, and if I don't do a key, the whole customer object, all the properties will become part of the key. However, for a specific reason which we will see later, I don't want the whole customer object as a key. Instead, I want my own defined key. I can do that using Spring Spell, um, the Spring expression language. So using the expression language, I'm saying on the customer object, go get the SSN, invoke the SSN method. It's all happening via reflection. So go get the SSN and use that as that as the key. So now what happens is that when I invoke the endpoint on this, when it saves for the first time, it's going to insert into the database, but then it's going to cache the customer with this key, which is SSN. So then later on, when I hit this endpoint, that's a get endpoint, because previously the SSN is cached, when I invoke this, it's not going to go find it. It's not going to write an SQL, reach out to the database and get the data. Instead, it's going to get it from the previously cached thing. So that's why I wanted to use the same key in both cases instead of the default key. And now one last thing, it's the book. Let's add a key for the book, but this time not into the customer, but books go into their own cache, under their own key. It's called book, and it's going to have the key ID. Actually, the net key would be something like this. Let's go back to the application properties. For example, let's see the book ID. What would be the key? The key would be based on the prefix, which we copied as demo cache. So the effective key would be something like this, demo cache. And the cache name we supplied in the cacheable part of the key, and the key, actual key, ID or SSN in the case of customer, and so on. What is common across all these things is going to be this, because that's at application level. With that, there is one more last thing that we want to do in the service. So that is to uncomment this thread.sleep. The reason for that is this. I want to simulate a latency situation, and that so when it first calls the endpoint and it invokes this method, first time when it is hitting the database, it waits, and then it connects to the database, does the select and retrieves the data. Same with SSN. But second time when it is cached, so the expectation is that when after the select is succeeded and the data retrieved, it is returned to the cache. That's the expectation. That's what the Spring cache is going to do. Once it is returned to the cache, second time when we invoke the endpoint, it's supposed to skip this whole thing, that because it's supposed to have a cache hit, not cache miss. So it's supposed to retrieve the data from the cache and skip everything. That means there is no delay. So to show how when it is hitting the cache, when it is not hitting the cache, the difference, I added this delay simulation, and we will do that in the book service as well. Okay, and the customer service, yes. With that, I think we are ready to test the Redis. Let's start the application again. And now I will open my Redis monitor, and we will also see what happens here. I'll clear. And go to the Postman and hit the first endpoint. That's the get. So here we are going to read from the database. And what happens when we read? The customer ID 1 is already there in the database as usual, as last time. And now let's hit. Because I simulated the delay of 10 seconds, now it's taking a while. And okay, so it got the data, and as you can see in the monitor, it did something. It created a key and a value. The value is nothing but the JSON itself. Now see this, the demo cache, that is the prefix that I was talking about, that we configured in the application.properties, which would be helping me to group all the keys under this prefix. And I'm going to use this prefix to denote an application, so I can manage my ECLs later, the security aspects later well. Now it hit the database, as you can see. Now let's hit the, now that the data is cached, now again hit the API and then see what happens. See, now the delay is not there, the 10 seconds delay, it's instantaneous. The response is instantaneous, and you wouldn't see any database access, a select happening. And now let's look at the RedisInsight and refresh. Now there is a new key that appeared. It's a JSON with the values. Now notice the key is 1, which is the ID. Now let's see what happens when you post to see the writing aspect of the cache. To do so, I'll go here. That's get still, I guess. Okay, this is a post, and I have a body, and I'm going to, I have two records. Now I'm going to make it 3, the third record. SSN is created as a unique key, so maybe I'll leave it 93. And just to make sure that there exists no record corresponding to that, let's do a select star from customer. And there are 2 records. Now let's get back to the Redis monitor again. And hit. I did not put the delay on the post, so it cached the data. And let's look at the logs. So there is an insert that happened, and now let's look at the RedisInsight. Refresh. There is a new key that appeared that looks like this, cached with an SSN. So the key is the prefix, and it's the customer, the cache named customer that I configured in the add cacheable, and the key that I explicitly configured, which is a customer using the spell, which is this. Now see what happens on the read aspect of it. Now when I'm going to fetch a customer using SSN. Now the SSN that I added, let's fetch first by a different one, maybe 2, because the 2 is not yet in the cache. It's going to delay, and after 10 seconds it's supposed to get me some, yeah, it got me the response. However, now the get of SSN for 3 is supposed to be instantaneous because we cached it as we write. So the write aspect of the cache. So let's see. So it's instantaneous. The 10 seconds delay is not there because it's picking from the cache, which is not cached by the get. It's cached when I did the post. So that's about the post aspect. Now let's see the look aside cache to pull the data from Google API. So that key is not here. This response is from the earlier call when we did not implement the caching yet. So there is no key for the books API. Now let's hit and then see what happens. Again 10 seconds delay because we are simulating the network latency or something like that. And now I got the response. Now let's go back to let's look at the monitor. So as you can see, it's a humongous JSON document. And yeah, this is the humongous serialized something. It cached. Now let's hit it again and then see what happens. And if you look at the monitor, nothing is written because it's already in the key, and all you see is get, not create or set. Basically there is no set, it's all get. So it's hitting the cache, and cache hit, so it pulls. When cache miss, it had returned to the cache. So that's the aspect of look aside and the the cache while writing to the database. Now I carefully, in my previous slide I said a type of read cache, a type of write cache. I explicitly did not say look aside or read through. I did not specifically say the type of the pattern. There is a reason for that. And the reason why I did not mention a specific pattern is because if you look at the Spring documentation, and how the catchable is implemented by default, if I don't do anything like how I did, it's more of a look aside. It's more close to look aside. That is, it looks into the cache, and if cache hit, it returns the value, and it skips completely the database operation. But if it is a cache miss, it fetches from the database, from the main data stores, and returns the value, and it also writes to the cache. To that extent, it's not inline, and it is more closer to the look aside type. But however, as a client using the Spring libraries and Spring abstraction, the client, that's my application, is not directly handling the interactions with the primary data source, and it's not, my application is not having the responsibility of managing this, and cache abstraction is doing it. First point. Second point is that Spring will complete the transaction if and only if the value is written to the cache, thereby ensuring the syncing aspect and the consistency. So if which is the point of caching inline. So that aspect is taken care by the Spring abstraction. So it's the whole transaction is going to fail if the cache is failing. And the third is a note, because I had seen people talking about it. I just wanted to confirm that Spring is not parallelly talking to both resources and sending the signals to both, and Spring is not canceling the signaling to the main resource if there is a cache hit. So there is no signaling aspect here and the waste of computation there. So considering all these three things, it, from the client perspective, from the application perspective, to the letter of it, it is more like a look aside. But going by the spirit of it, if you take the spirit of it, it's achieving what probably the inline cache is intending for. So it does not make much of a difference whether it is this or that. And now, can you make it truly look aside? I don't know. It depends on really the use case. I don't know why you would do it. There is some work that need to be done additionally, so you can make it happen. But for the reasons that I explained, I don't see a specific use case or a reason to do so in this situation. If there is a use case and there is a reason, yeah, there is a Spring documentation which I included at the bottom of the slides. You could do it. And with that, I think the demo aspect of the part 1 is done. But let's see some use cases and pitfalls, which is what I think left over. Yeah, the points worth noting: when to cache, what to cache. And the fundamental premise of caching is, when given the same arguments, if a service call yields the same results every single time and source is not changing frequently. What that means is, I copied this from I think Spring documentation, or maybe one of the Redis sites. But this is the definition. This is the fundamental premises that is documented there. So what that is saying, this is saying to us is that you go for caching when you have deterministic nature, more deterministic nature of the output, meaning you are sure that the data is not going to change for a given key every single time you send the same key. If it is changing, that means it's not a good candidate to cache. Plus, if the data is frequently changing, that means you are going to see all the time the cache hits. No, cache misses. That means it's not adding any value, it's an overhead. If every single, which means you are every single time or every other time you are hitting the database or the API, then what's the point in caching? So you don't cache in those cases. So that's the point number 1. And few examples of such situations or the use cases why you would do is, for example, searching in our case, searching for a customer in the database using a unique key like account ID, SSN. If it is returning the same customer and the customer is not changing fundamentally the properties every frequently, then it's a good candidate to cache. Similarly, the other specific example I took is for pulling a doctor. So this is more relevant to the healthcare industry or such. So if you are pulling a doctor information from a third party API using NPI, which is a unique identifier, and it's not changing frequently, and every single time you pull the doctor using an NPI, it's the same doctor, it's not going to be a different doctor. So this is another good candidate to cache using the API when the data source is API. Now, pitfalls. This I copied from Spring documentation again, talking about the side effects or the pitfalls. This is saying there are still moments when the cache could be observed in an inconsistent state relevant to the backend database, such as between the database update and cache refresh on a cache hit. So I'm not going to read this whole thing, but essentially what this means is that there are multiple clients modifying the cache, which is not unusual. That's what the distributed caching is for. So there could be multiple instances of the same application or a different application. Both are writing to the distributed cache in the same way, fetching in the same way. That's not an issue. But suppose there is a legacy application and it's avoiding the distributed caching completely and directly, suppose it is accessing a database and writing to the database. Now these the writing to the cache is missed, so there is a gap there. So unless and until the TTL arrives and a particular entry is expired and recached, it's stale data. So you have to take care of those things. And then the other possibility is that you are letting some manual updates to happen. So somebody manually went to the database and updated. There is no way for the application or the cache to know that the data is updated elsewhere from a different resource. So the cache is still. The other example could be your housekeeping jobs. Housekeeping jobs, if they are not if they are not using this, if they are not writing or reading through the same caching mechanism, then it is a possible, most times probably that's how the housekeeping jobs are written. They are not doing anything with the caching. They come and they die. But this is an easy case to be handled. The key is, as they are because the jobs are more predictable, and you know when they are running and what kind of data is changing and all that. So we could, in these regular intervals, probably, let's say it is a nightly job, so after the job is run, we could probably have a write catch eviction policy and refresh cache mechanism um, to expunge the cache or takes those entries. And then again, when the application, the client that is implementing the cache runs, it could, because it is look aside, if there is a cache miss, it will cache again. But there is one caveat again here, that is, if it is a huge amount of data, now again to populate the cache and to get to the state where it started, it will take a lot of time. So the other trick here could be hot loading. Once your job runs, probably you could have a job, to a task to hot populate the cache, so it's available, it speeds up the client. So those are few ideas, pitfalls, and maybe a few ideas to handle. Let's see. Okay, we are on to the part 2. With that, I'm going to conclude the part 1 of the demo, part 1 of the session, and we will meet again in the part 2 of the session, where we are going to look into the Redis security aspects, and we are going to incorporate security into this application that we just built. So far, it's using the default user that can do everything, that can access everything, every single key that's possibly available in the Redis cache. So we will incorporate the security and then see what that means in the part 2 of the demo.